I am welcoming you all to this session. In this video, I am going to discuss about three topics. One is the Joule's experiment. Second topic is the first law undergoing a cycle. Second, the first law undergoing a state. See one by one. The first topic in this video is the Joule's experiment. Joule's experiment. Joules conducted so many experiments in the period of 1842 1849. He conducted so many experiments. Out of this is one of the example. This is one of the experiment he conducted. Now we going to discuss. Let me first explain the about this. This is a closed container with a this is a closed container. Okay, closed container which is an adiabatic boundary. That means it is an insulated, perfectly insulated. We taken and it is filled with a known mass of m of fluid, water. Known mass of water is taken into the tank, and initially the water temperature is at T1. Initial temperature of the water is the T1. Water temperature is the T1. Pressure is taking, let the atmospheric pressure. This is a known weight W. A known weight W. Initially, okay, this is a general coordinates. Take x and y. Okay, now first initially the work is done on the system by lower the weight through this. By this we can know whatever the work done on 1 to 2 is the we can calculate by the mgh. Due to the work on the system, the pedal will get still. Due to this, the temperature will rise to T2 at state 2. The temperature will rise. That is, if you plot on this, the work transform from state 1 to state 2 is W1 to 2. 1 to 2. Because of this is a adiabatic and fully insulated, so there is no chance of heat is transferred through this, so the temperature of the water is get raised. Next, this is the first case at the insulated condition. Next, if you remove the insulation, no insulation, let the water gets to cooled until it reaches to atmospheric temperature, that is the T1. At T1, now the work is transformed to 2 to 1 process. Now the work is transferred to 2 to 1 process until it reaches to its original temperature. That means in 2 to 1 heat is transformed from the system to surroundings. If we remove at the no insulation condition, he noticed here whatever the work done in the he noticed that Here the amount of heat transferred also can be calculated by the known mass of mcp delta T or T2 minus T1. From these two values, he noticed that he found the work done, the work transfer is always proportional to the heat transfer, always proportional to the heat transfer. Now here I taken a simple example, only two energy interactions are involved. He also conducted with the so many n energy interactions, even though he noticed that yeah, he noticed that same result will be found, that a sum of all heat in a cycle, sum of all in a cycle is equal to the summation of all the work done in a cycle with the joules. He noticed this. He noticed this. He noticed this. He found that he, he, he found that J is a ratio of W by Q is the same for any conducting the experiment of a complete cycle. He noticed that founding the same. This is from the Joule's experiment. This is the first this so it is this is the first law for a closed system undergoing a cycle. It is accepted as a general law for a nature. Since there is no violation, it has been ever been demonstrated. The units of the work is joules. The units of work is joules. Q is joules. So the work, the units of work is joules. Q also joules. Joules is a Newton meter. Newton meter. Newton meter. Newton meter. So J comes the units as a unity. J comes the unit as a unity. Here the joules is done so many experiments. He also done an experiment with instead of water. Here instead of water he replaced with mercury. Also he done it the same experiment, and he concluded that whatever the fluid is used here, and he get the same conclusion. The summation of all the cyclic integral summation or cyclic integral of all work done is proportional to the cyclic integral of the work the heat transfer is equal to summation of all work done is equal to the summation of all the heat transfer through a complete cycle. He found this, and he also done it with the experiment by using stones also in this. If we, by placing here stones, the work is observed by the because of that friction, the work is observed and it gets heated due to this work and the temperature rise. So from this also he concluded what he done n number of experiment. Whatever the experiment, he found the same ratio. The ratio of W by Q is the same for all the experiment. So from this he given this law: summation of all W, summation of work in a cycle is equal to the summation of heat transfer through a cycle. Heat transfer through a cycle. Before the joules, okay, earlier to the joules, earlier to the joules, the heat is considered as an invisible fluid. Okay, before the joules, the heat is considered as a invisible fluid which flows from a higher higher calorific value, higher calorific body to the body which is a lower calorific, low calorie. This is known as a caloric theory of the heat. It was the first, the Joule was who was Joule is the who first established that the heat is a form of energy, and this is laid the foundation of the first law of thermodynamics. Okay, Joules concluded that whenever the system undergoes a cyclic changes, whenever the system maybe undergoes a cyclic changes 1 to 2 and it returns to its original position, whenever the system undergoes a cyclic changes, if maybe the n number of complex cycle also, n number of initial state and final state is the same, if the system undergoes n number of process with a process also complex also, the algebraical sum of the work transfer in a cycle is equal to the algebraical sum of the heat transfer. It can be also be write as a cyclic integral of dq is equal to the cyclic integral of dw. This is the work done on the system and work transfer from the this is heat transfer from the system. I am talking in this case the work is done on the system, on the system, and heat is transferred from the system from the system This is the case for a closed system. This is the first law of thermodynamics of a closed system. A closed system undergoing a cycle. A closed system means a non-flow process. Non-flow process. Open system is a flow process. In the earlier videos we discussed very deeply about this distinguishing or the variation between the difference between the open system and closed system. Okay, so we should not get any confusion about the closed system or open system. What is the non-flow system, what is the flow system? Okay, open means it is ready to a flow, so it is a flow process. A closed system means it not allows a mass to flow through this, so it is called as a non-flow process. This is the first law of thermodynamics for a closed system undergoing a cycle. Now we see first law applied to a change of state. Now we see the first law of thermodynamics for a closed system undergoing a change. Before this, we seen the first law of thermodynamics for a closed system for a cycle as this expression we seen for a cycle. This can be write as a q sigma q cycle minus sigma w cycle is a 0. By this, the algebraical sum of the heat and work in a cycle as a 0. Suppose if a system undergoes a change from position 1 to position 2, if the system undergoes a change a state from a state 1 to a state 2, in this process both heat and work is involved, if the both heat and work is involved, both work and heat and both work and heat is involved, then the net accumulated energy are the stored in the system, we, we called as a internal energy. Suppose this is a system. Suppose this is a system. Suppose this is a system. The amount of heat is entering and work is done by the system. The net amount of energy is stored or accumulated in the system we called as a internal energy. The algebraical sum of the energy, algebraical Q minus W is equal to the internal energy. This can be used as a definition of the internal energy also. Q, from this Q equal to delta E plus W. Delta E and Q is the amount of heat transfer to the system. W is the work transfer from the system. The net energy transform is the Q minus W. But this equation not gives the absolute value of the energy, but only the change of energy delta E for a process can give this expression. If the system involves two energies, this if the system involves n number of energies, also applies the same. If system applies n number of energies, suppose this is a Q is entering, Q1 is entering, Q2 is leaving, Q3 is entering. Now W1 is we know that the summation of these two Q, whenever the heat supplied to the system is always the positive, heat is leaving, so negative Q2. Q3 is supplying the heat, so it is a positive. I am writing this Q delta E is the same. Now the W, work done by the system means W is a positive, work done on the system W2 is the negative, and work done by the system is the positive. This way we can write if the process is involved n number of energy interactions also, we can write this way by using this a basic formula, which is the first law of thermodynamics, undergoing a change of state. We can write this. Now we can see, if we see the simple example, okay, by the end of this third topic we will see the one numerical example which will be clear to whatever we discussed. It will give a clear idea. Let me complete this third topic also. The energy is a property of a system. Let me prove this energy is a property of a system. Let the plot. If a system undergoes a state from 1 to 2 through a process A or a path A, and it returns from state 2 to the 1 through a path B. Another way, alternately, if the system is changing from state 1 to state 1 to 2 through a path C and returns from path 2 to 1 through a path B. Now we apply the, let it be a PV plot. First we apply the first law of thermodynamics. First law of thermodynamics for a changing a state, for a change of state, that is a for a path path A path A Q delta E plus W is the first law of thermodynamics for a change of state. Q A is equal to the change in energy, and it returns the work involved in a process A. A is here the change of energy, only writing path A. Now a path B, same, QB, change of energy in B, W in B. Now it both together consists a cycle. Now both together it completes a on cycle. From this cycle, the first law of thermodynamics, the formula is the algebraical sum of the work involved in a cycle. It should be equal to the algebraical sum of the heat through a cycle. Now W A plus W B should equal to the QA plus QB. Now I am writing here WA, simple mathematics, just changing B W. From this we can write this as a W1 minus A. From this we can write as a this is writing a equation 1. Now you go through 1 C to B1. This is a cycle. If the system is changing from state 1 C to B1, this, if we consider this is a on cycle, and we can write first cycle is like this. The path is starting from 1 and through a path A, and 2 it returns to its position through a path B. Here the system is starting from 1 and moving forward with through a path C line and return to path B to its one and completes a cycle. Here also completes a cycle. First applying the first law for change of state for a path B. Similarly, Q of C, change of energy C plus W of C. For path A already there. From this to Q of A, change of energy of A. This is for path. This is a path C. This is a path A. Path A and path C together consist a cycle. First law of thermodynamics, undergoing a closed system, a cyclic process. We can write the summation of the work in the cycle is equal to the summation of the work heat transfer through the cycle. work transfer through a cycle is the WC plus WB. Can be write it as a Q of C, Q of B, and Q of C minus Q of C. This is the simple mathematics. I am writing QB and WB. This can be write as a Q of C minus Q of B. Q of C minus Q of is a minus of delta C is equal to the QB minus W is a delta XB. This is the equation 2. From 1 and 2 we can notice that the change of energy through A is equal to the change of energy through SC. Therefore the change in energy is the same. Change of energy is the same between the same state, whatever the path is followed, even though the change of energy is the same. By this energy have a definite value for every state of the system. Up to now we discussed about the first law applied undergoing a cycle and undergoing a state of change. Now by solving this example, we get a better understanding of the whatever we discussed about the concept of first law of thermodynamics. The problem was given that there is a one cycle 1 2 3 1 2 3. If the system is changing from position 1 to 3 through a 1 2 3, this is a one path, and another path is 1 4 3, this is the another path the system is undergoing. Okay, he given the data the path 1 to 3, the system absorbs 100 kilojoules of heat, and it does a work of 60 kilojoules of work. And if we take the path 143, it does 20 kilojoules of work. Then what is the heat observed during the path 143? He given and he asked to calculate what is the heat transform through 143. This is a change of state. Change of state. From the first law of thermodynamics we have a relation, that is the Q is equal to the change of energy delta E plus W for a change of state. By using this we are going to solve. First 1 2 3 path. Here Q is given 100, here W is given as 60. A simple substitution here, 100 is equal to the delta E plus 60. From this delta E is equal to the 40. We know the energy is a property of the system, so energy is only depends upon the end states. It is independent of the whatever the path is followed. So energy, change of energy between the two states is same. So 143 path also, by applying the first law of thermodynamics, this is the same formula. Q is equal to the delta E plus W, and he given W as at 20 kilojoules. He asking what is the Q. We know delta E from the concept of, and energy is a property of the system. It is it is independent of the path followed by the system. Whatever the path followed by the system, the change of energy will be the constant. So we using this relation and substituting the 40 here. From this finding, 40 plus 20 is equal to the 60. Answer is the 60. At the end of this first law of thermodynamics chapter, we will discuss at least 10 problems, 10 variant problems we will discuss. First we complete the concept about the first law of thermodynamics one by one. Thank you.